Hi everyone, welcome back to our 15 minutes physics class. Well, I think many of you are familiar with this three picture, isn't it? Yes, there are the picture of nuclear reactor. And of course, these picture are related to our topic for today. So today, we are going to learn nuclear energy in 15 minutes. First, let us see the learning outcome for today's lesson. There are two topics under Content Standard 6.2 Nuclear Energy that we are going to focus on, which are 6.2.1 Communicate about nuclear reactions, nuclear fission and nuclear fusion. At the end of this lesson, students must able to compare between nuclear fission and nuclear fusion. The second topic is 6.2.2 Describe relationship between energy released during nuclear reaction and mass defect through the equation E equal to mc square. 6.2.1 Communicate about nuclear reaction, nuclear fission and nuclear fusion. Before we go further, let us see the concept map. There are three types of nuclear reaction, which are radioactive decay, nuclear fission, and nuclear fusion. This nuclear reaction will produce a large amount of energy. The energy produced by nuclear reaction is known as nuclear energy. Nuclear reaction also can cause the loss of mass of radioactive nucleus. The loss of mass that happens after the nuclear reaction is called as mass defect. But before we talk about nuclear fission and nuclear fusion, do you still remember about radioactive decay that we had learned in previous topic? No? It's okay. Let us recall about radioactive decay together. Radioactive decay is a process in which an unstable nucleus becomes more stable by emitting radioactive radiation. Radioactive decay is a random and spontaneous process because it is not influenced by temperature, pressure, or other physical process. And there are three types of radioactive radiation, which are alpha particle, beta particle, and gamma ray. Now, we can start our lesson about nuclear fission. From the word fission, do you get any idea on what happened in nuclear fission? The word fission means division or splitting into two or more parts. Therefore, nuclear fission is a nuclear reaction when a heavy nucleus splits into two or more lighter nuclei while releasing a large amount of energy. In nuclear fission, a neutron is bombarded to excite the heavy nucleus. Now, look at figure 2. We can see the target nucleus, which is referred to the heavy nucleus, is bombarded by a neutron. The bombardment has caused the target nucleus to split into two small nuclei, or usually called as lighter nuclei, and produce three neutrons as well as a large amount of energy. Now, let's see the example of nuclear fission involving uranium-235. Uranium-235, which is the heavy nucleus, is bombarded by a neutron. The bombardment has caused the production of an unstable uranium-236 nucleus. The unstable uranium-236 becomes stable by splitting into two lighter nuclei, which is barium-141 nucleus and krypton-92 nucleus, and also produce three neutrons and a large amount of energy. This nuclear reaction also can be written in the form of equation as shown below. We come to the third nuclear reaction, which is nuclear fusion. Nuclear fusion is a nuclear reaction to form a heavier nucleus while releasing a large amount of energy. This nuclear reaction happens under extremely high temperature and pressure. Figure 4 shows that in nuclear fusion, two lighter nuclei will combine or fuse to form a heavy nucleus and release a large amount of energy. This is the example of nuclear fusion involving deuterium and tritium. The deuterium and tritium are heated to cause the fusion reaction to happen and produce a heavy nucleus, which is a helium, a neutron and energy. This nuclear reaction also can be written in the form of equation as shown below. Until this part, are you clear about nuclear fission and nuclear fusion? Is anyone feel confused about this topic? It's okay, let us make it clear through the table of comparison of nuclear fission and nuclear fusion. This is the comparison between nuclear fission and nuclear fusion. For nuclear fission, the keyword is split, where the heavy nucleus will split into two lighter nuclei and produce energy. The heavy nucleus is excited by a neutron that is bombarded to it. Meanwhile, for nuclear fusion, the keyword is fuse, where two lighter nuclei fuse to form a heavier nucleus and produce energy. Nuclear fusion happens under extremely high temperature and pressure. I hope this comparison can help everyone to understand clearly about nuclear fission and nuclear fusion. Now, it's time for us to check your understanding about nuclear fission and nuclear fusion. Question 1. Figure 6 shows a nuclear reaction. The question is, which of the statements given is related to the type of nuclear reaction shown in Figure 6? To answer this question, first you have to look at the figure carefully. We can see a neutron with an arrow point to the target nucleus, or in other words, a neutron is bombarded the target nucleus and produce two fission products and three neutrons. So, we can conclude that the figure shows the process of nuclear fission. Therefore, we have to choose the answer that related to nuclear fission. Before that, let us go through each answer given together. A. The nuclear reaction produces a heavier atom. In nuclear fission, after the heavy nuclear splitting, it will produce two lighter nuclei. So, A is not the answer. B. No energy is produced from this nuclear reaction. Every nuclear reaction will produce energy. So, B is not the answer. C. Two lighter nuclei are produced from this nuclear reaction. Yes, this is what happened in nuclear fission. And D. The nuclear reaction shown is nuclear fusion. As we have discussed before this, the nuclear reaction shown in the figure is nuclear fission, not nuclear fusion. Therefore, the answer for this question is C. Let us move on to question 2. It shows an equation for a nuclear reaction. Which of the statements given is related to the nuclear reaction shown above? First, look at the equation carefully. It shows that the addition of two hydrogen atoms that produce a helium, a neutron, and also energy. So, we can conclude that the equation is belong to nuclear fusion. It is because in nuclear fusion, two lighter nuclei is needed to form a heavier nucleus and produce energy. Therefore, we need to choose answer that related to nuclear fusion. So, the answer is A. Now, let us move on to the second learning outcome for today, 6.2.2. The relationship between energy release during nuclear reaction and mass defect. In nuclear reaction or radioactive decay, the total mass of decay products is always less than the total mass of radioactive nucleus, and the loss of mass after nuclear reaction is known as mass defect. In figure 7, it shows that the mass of radioactive nucleus is larger compared to the mass of decay product. The mass of the heavy nucleus will decrease after it split into two nuclei. To make it clear, let us see the example of a change in total mass before and after nuclear fission. The first step to calculate the mass defect of this reaction is to calculate the total mass before fission. There are two particles involved in this reaction, which are a neutron and a uranium. Therefore, we need to calculate the total mass of these particles. The total mass before fission is 236.05259 AMU. After the reaction happened, we need to calculate the total mass after fission. The total mass is calculated by adding the mass of barium, krypton, and 3 neutrons. Then, the summation of the total mass before and after fission will be the mass defect of this nuclear reaction. The relationship between the energy released during nuclear reaction and the mass defect can be summarized by the following equation: E equal to mc square, where E is the total energy released during nuclear reaction, m is the mass defect, and E is the speed of light in vacuum. This equation can be used to calculate the energy that is produced from radioactive decay processes and nuclear reaction. Now, let us solve a question related to mass defect. The Sun is the source of energy to the Earth. This energy is produced by the nuclear fusion in the core of the Sun as shown in the following equation. The question is, calculate the nuclear energy released through this nuclear reaction. In order to solve this problem, you are advised to follow these 4 steps. The first step is to identify the problem. The second step, identify the information given. The third step, identify the formula that can be used based on the problem and the information given. The last step is to solve the problem numerically. Based on the question, the problem that we need to solve is to calculate the nuclear energy release. The information that we need is given under the question. And the formula that we need to use is E equal to mc square. By using the information given, we can calculate the mass defect of the nuclear fusion. The total mass defect of the nuclear fusion is 0.018 AMU. Then, we need to change the unit of the mass defect to kilogram by multiply the 0.018 AMU with 1.66 times 10 to the power of negative 27 kilogram. So, the new value for mass defect is 2.988 times 10 to the power of negative 29 kilogram. Then, use the equation of E equal to mc square to get the value of nuclear energy of the nuclear fusion. So, based on the calculation, the value of nuclear energy released through the nuclear fusion is 2.69 times 10 to the power of negative 12 joule. Therefore, the answer for this question is A. That's all for today. If you have any question regarding today's lesson, please don't be hesitant to ask me. Thank you for your attention.